Coordinating developers, tracking thousands of bugs, and processing millions of data points daily requires structure. Without it, this activity degrades into pure entropy. In a startup, informal communication works because you can simply ask the engineer next to you. But as an engineering organization scales, those informal networks snap. Teams isolate into functional silos, utilizing different tracking tools and speaking different operational languages. This creates an operational blind spot where the ground truth of what engineering is building becomes disconnected from the strategic roadmap. Scaling an organization requires an engineered architecture for work abstraction and feedback. We have to design systems that handle the data routing automatically. We are going to build an enterprise DevOps system from the ground up by integrating GitHub source-level tracking with Azure Boards portfolio management. This integration creates an unbroken chain of data. A single commit made by a developer systematically traces all the way up to the executive roadmap. True agility at the enterprise level relies on structurally engineered work abstraction. Every layer of the organization must receive exactly the context it needs to make decisions. The foundation of this system begins with tracing the smallest unit of work, a single code commit. To track commits, we implement GitHub Flow. Active development branches off a stable mainline, merging back only through a mandatory pull request gate. Semantic commit messages enable automated processing. These standardized text labels sort changes into specific pathways, generating changelogs without manual oversight. Implementing atomic commits ensures each change represents one logical update. This provides the precise traceability required for rapid debugging and rollback capabilities. Managing the codebase creates a parallel requirement, aligning multiple teams through structured communication. Ad hoc repository issues often fail at the enterprise level because they lack the scope to facilitate cross-team collaboration across a large organization. Instead, we deploy enterprise GitHub discussions, categorized strictly by function. We establish specific buckets for strategic planning, architecture decision records, and sprint retrospectives. Architecture decision records preserve institutional memory. They document the rationale behind technical choices, ensuring that new team members understand the history of the codebase. Enforcing structured inputs for both code and conversation prevents the formation of unsearchable data silos. With the source layer established, we connect pull requests upward into project management tracking. Azure Boards provides a rigid hierarchy. Pull requests connect to tasks, rolling up to user stories. Stories form features, aggregating into epics. This hierarchy adapts to your process. Agile uses stories and features, while Scrum utilizes product backlog items and sprint ceremonies. Organizations in highly regulated industries often require the CMMI process. It introduces formal change requests and risks to satisfy strict audit and compliance frameworks. With the hierarchy defined, we map our team structures to these specific paths. Cross-functional feature teams focus on autonomous delivery. By including developers, testers, and designers in one unit, they reduce dependencies and accelerate the development cycle. Component-based platform teams support them by managing shared services and specialized infrastructure domains. These team structures map directly to area paths in Azure DevOps, ensuring clear ownership of every work item. Aligning the work hierarchy with the organizational structure enables granular permission inheritance and clear accountability for every deliverable. We now introduce the dimension of time-boxed planning into our work hierarchy. Iteration durations match team function. Maintenance teams use 1-week cycles for rapid fixes. Agile teams use 2-week cycles for predictable delivery. We also embed strategic breaks into the cycle. Dedicated blocks for architecture planning and tech debt ensure quality doesn't degrade as projects scale. To manage the data generated during these iterations, we need continuous feedback cycles. We manage this through a stakeholder notification matrix, which routes information based on role and urgency. Critical alerts, such as build failures or blockers, are routed immediately to developers through real-time channels like Microsoft Teams or Slack. Regular updates, such as velocity metrics or sprint progress, are batched for product managers and delivered through weekly dashboards. This strict routing logic prevents alert fatigue and preserves engineering velocity by filtering the noise out of the developer's workflow. Integrating code, tasks, and iterations results in a data graph with deep layers of technical and operational detail. We manage this complexity through strategic abstraction. Using project views in GitHub and Azure Boards, we can transform the raw data into interfaces tailored to specific roles. The board view layout clusters work items by their current workflow stage. This view is optimized for development teams tracking daily sprint progress and identifying immediate bottlenecks in the pipeline. The table view provides a spreadsheet-like interface, sorted by business value and effort estimates. This layout helps product managers conduct backlog grooming and perform bulk data analysis across the entire project. The timeline view groups work by milestone to provide a Gantt-style visualization of the schedule. This serves executives and program managers who need to coordinate cross-functional dependencies and long-term release dates. Abstracting the unified database into role-specific interfaces ensures that data drives immediate contextual action. By combining these components, we can trace a single event through every layer of the organization. It begins at the foundational code layer, where a developer pushes a semantic commit to resolve a critical software defect. That commit links through a pull request gate, automatically updating the status of the associated task in Azure Boards. As the task closes, the parent user story is marked for a quality gate test, ensuring the fix meets established standards. The final result is a visual shift in the progress bar of a strategic epic on the executive timeline. This creates a complete loop between source, bug, and quality traceability. Engineering organizational telemetry ensures that every line of code maps directly to a strategic portfolio objective.